Hello, my dear students. In this section, we are discussing about voltage regulators. We already discussed about DC power supply section, which includes transformer, rectifier, filter, and now we are going to discuss the last part of DC power supply, that is the voltage regulator. Here, we are going to discuss about Zener Diode, its VA characteristics, its application, and then how a Zener diode works as a voltage regulator, its line and load regulations. We know that the ordinary diode has unidirectional property, that is, the current will flow only in one direction when it is in forward bias condition. In reverse bias condition, it offers high resistance, that it acts as an open circuit, where the Zener diode is designed to operate in the reverse breakdown region. In forward bias condition, it acts like an ordinary diode. If the reverse voltage exceeds the breakdown voltage, the Zener acts like a constant voltage source. That's why it is called voltage reference diode. The figure shows the symbol of a Zener diode. Zener diodes are available with breakdown voltages from 2 volt to 200 volt. Zener diode is specified by its breakdown voltage and maximum power dissipation. We have already discussed that Zener diodes are designed to operate in breakdown regions. There are two types of breakdown mechanism. They are avalanche breakdown and Zener breakdown. The first, avalanche breakdown. Avalanche breakdown is a cumulative action. The applied reverse bias voltage accelerates the minority carriers in the p-n junction. These minority carriers attain kinetic energy and they collide with the atoms and creates new carriers, which are again accelerated to high velocities to ionize more atoms. So the reverse current increases sharply. Next one is Zener breakdown. Zener breakdown occurs in heavily doped diodes. In heavily doped diodes, the width of the depletion region is narrow. When the reverse bias voltage increases, the electric field across the depletion layer also increases. This field breaks the covalent bond and electrons are pulled from the covalent bond. This effect is known as Zener breakdown. Now the VA arrow of Zener diode. Here the graph shows the VA arrow of Zener diode in forward bias condition, that is anode is connected to the positive terminal and cathode is connected to the negative terminal. The diode acts like an ordinary diode. In reverse biased condition, anode is connected to the negative terminal and cathode is connected to positive terminal of the battery. When the reverse bias voltage exceeds the breakdown voltage, the current increases sharply, which is due to the breakdown mechanism that we discussed earlier. We have seen in VA era, the Zener breakdown happens in less voltage than avalanche breakdown is due to heavily doped diodes. The main application of Zener diodes comes in voltage regulator circuits, peak clippers in wave shaping circuits, fixed voltage reference in transistor biasing circuits. Then, then we are going to discuss about voltage regulator. The figure shows the circuit diagram of a shunt voltage regulator. To work Zener diode as a voltage regulator, it must operate in reverse breakdown region. The Zener diode is connected in parallel to the load resistor. That's why the circuit is called shunt voltage regulator. To design a Zener voltage regulator, Vs should be greater than Zener breakdown voltage. For designing Zener voltage regulator, we should find the values of Rs and RL. Rs resistance can be found out by Rs max equal to Vs max minus V0 divided by IL minimum plus Iz max, where Vs is the unregulated supply voltage and V0 is the regulated output voltage and IL minimum is the value of current flows through the load resistor and Iz max is the value of current flows through the Zener diode. And we should find the value of load resistance. Load resistance can be found out by RL min is equal to V0 divided by IL max. Then we are going to discuss with line regulations with varying input voltage. The output voltage of a circuit may be varied either by changing the input voltage or change in the load resistance. For finding the line regulation, the first case is considered, that is change in the input voltage. Here in the circuit diagram, Vs is varying and R is kept constant. When the input voltage Vs is increased, then input current Is also increases. As we know, Is is the summation of Iz and IL, that is Is equal to Iz plus IL. If Is is increased, there will be a change in either Iz or IL or both. As we know, Zener is operated in breakdown, its current increases sharply. That is, the increased current will flow through the Zener and IL kept constant. The increased input current will also increases the voltage drop across Rs, therefore the output voltage V0 kept constant. The line regulation is the ratio of percentage change in output voltage to the percentage change in the input voltage. That is, next we are going to discuss about load regulations. For finding load regulation, the input voltage is made fixed and the load resistance is varied. That one is shown in the figure where Vs is fixed and RL is variable. When load resistance is increases, the current through RL decreases. From this circuit, input voltage is kept constant, therefore Is becomes constant. That is, Is is equal to Iz plus IL. The resistance is increased, so the current through RL decreases. To keep ISS constant, the decreased amount of current flows through the Zener diode current IZ. Therefore, output voltage becomes constant. The percentage change in load regulations equal to no load voltage minus full load voltage divided by no load voltage into 100. In this section, we covered the topics Zener diode, its breakdown mechanism, and its application as voltage regulator. I hope you got the basic knowledge about these topics. Thank you.